Hey everybody, welcome back to Learning Applied Behavior Analysis. This time we're talking about graphing behavior and measuring change because the way that we represent and analyze things matters. First up, let's talk about how we represent our data. We talked at some length previously about how we record it, how we define the behavior that we're observing, what methods we use to record it, and what the pros and cons of all the different approaches are. Let's talk about sort of the basic idea of how we take that data that we record and how we represent it. Okay, so most of you know your way around a graph by this point. You've made it through the stat sequence and you have graphed a good amount of data yourself. But the book spends a lot of time on it, so I'm going to at least refresh all of you on the basics of a graph. So the y-axis and the x-axis. The y-axis being the vertical axis and the x-axis being the horizontal one. You should have labels for these things. They should be clear, descriptive labels that are very unambiguous and easy to understand. In this example, we have hours of studying and days. So in addition to that, we need to have numbering of our axes, right? Here we have 0 through 20 for days, and then 1 through 5 for hours spent studying. Next, of course, we need to plot our data onto this graph. So here, we just have what's basically a simple histogram-like line graph where we have the number of hours spent studying as a function of day, sort of plotted and connected here. Okay, so this is something that might not be as familiar to all of you. This is a phase line. You can see here this dotted line is clearly meant to separate two different aspects of our data. As you can see here, we add those phase labels. We see that this, the first period of time here is baseline period, so before any sort of treatment. And here is our experimental portion where the behavioral contract is in effect. And you can see here that this little line clearly demarks the baseline from the behavioral contract time period. This is something we'll see a lot. We'll talk more about research designs here shortly, but when representing our data, we want to clearly be able to delineate between the different phases. Okay, so this is a little depiction of how we can get something from like a data sheet converted into a graph. So we can see here that we have the number of days plotted, 1 through 14, which corresponds to our x-axis here. Then we have the frequency, or the number of cigarettes smoked, which corresponds to our y-axis here. So basically, every time this participant has smoked a cigarette, they put an X on the frequency box, right? So counting up 1 through 8, we can see here there's a variable amount of cigarettes smoked per day. And then here, where we have our phase marker delineating our baseline from our behavioral contract, we can see the change when the behavioral contract is online. And the number of cigarettes smoked per day decreases. So basically, we just want to take this daily total and then plot that along the days. Okay, here we have a different sort of data recording sheet. So this is tracking a participant's time spent exercising. So instead of recording discrete events, we're recording the amount of time, the duration spent engaged in exercise. So we have an onset and offset. So here on day 2, we have an onset of 7 and offset of 7:15. So the duration we can record for the day is 15 minutes. You can see here similar data throughout. Right, so 7:30 to 8, that's half an hour of duration recorded. Here we have 2 different exercise episodes that total 45 minutes. So basically we have our actual data recording apparatus here where the participant is recording when they start and when they stop exercising, potentially across multiple exercise episodes. Then they tally that into a daily duration. Then that data can be graphed. So I've inadvertently cut off the x-axis label of days, but you can see the y-axis label of minutes of exercise. And we have a number of days of baseline behavior already recorded here. And basically what we need to do is take that column from the previous page where we have our day and the duration of exercise per day, and then map that onto our graph here. So you can see we have a line here delineating which phase we're in. When the behavioral contract is in effect, we see an increase, right? So we can have the amount of time spent exercising per day plotted nice and cleanly. So your book is kind enough to include this little box here for further reading. Though it's easy to construct a graph with a piece of paper, ruler, and a pencil, there are graphing programs that allow you to construct a graph on your computer. So in case for some reason you've made it to 2021 and an advanced class in college without knowing how Excel works or PowerPoint, they encourage you to look into that because it may be a superior option to using graphic paper. So keep that in mind. Okay, let's talk a little bit about research design and learning ABA. What the point of doing this as a sort of scientific research approach is to help us determine whether the treatment or our independent variable is responsible for the observed change in the target behavior or our dependent variable. Good design seeks to rule out that extraneous variables caused the change. This is all very likely review to you, as you have made it through a stat sequence and a number of classes in the psych major that have taught you quite well at this point what an IV and a DV. So the independent variable is the thing that we're manipulating, right? It's our treatment. If, for example, you're trying to stop smoking and you enter a behavioral contract where you receive a token, for example, if we're going to use a token economy, for every day that you decrease the amount of cigarettes you're smoking. That would be your treatment. And the target behavior would be something like, number of cigarettes smoked per day. That's our dependent variable. The dependent variable, the target behavior, depends upon this treatment, right? So we're trying to see if there's a relationship. If the treatment that we introduce is responsible for the change in the target behavior. So we want to rule out extraneous variables that cause the change, so we're doing this in a nicely controlled manner to try to make as strong of a claim as we can. Again, the independent variable, what the researcher manipulates to produce a change in target behavior. The dependent variable is the target variable. What are we measuring? So you might be thinking, well, what do I care? If I implement some kind of behavioral program for myself and it works, what do I care if it was the actual treatment or some other thing? And the answer is you might not. For individuals, knowing the behavior changed was probably enough, right? If you're trying to stop smoking and you stop smoking, you probably don't care why it worked. But for researchers, we want to know causality, right? If we're trying to figure out a good treatment plan, we have to tightly control things to know why the plan worked for you. So hopefully we can make that plan work for other people. So we want to establish what's called a functional relationship. A functional relationship lets us know that the behavior modification procedure caused a behavior to change, right? It caused it. We want to know that that causal factor is there. We can say that a functional relationship is established if the target behavior changes when the IV is manipulated, while all other variables are held constant, and the process is replicated or repeated one or more times and the behavior changes each. So those are the two critical things, right? We want to manipulate the IV, we want everything else to stay as constant as possible, and we can't just do it once, right? We want to make sure we can either go back and forth or demonstrate it multiple times in different ways. We're going to spend the rest of this unit talking about the ways that we can do that. All right, so to sum up, this is the basic idea that we're going for here, right? We measure the dependent variable, or our target behavior, to establish a baseline. Then we manipulate the independent variable, right? So we attempt to demonstrate a change in the target behavior, and then we replicate it by doing it again. That might be within the same subject, right? So, for example, we have this graph over here. So here we're graphing the percentage of intervals of disruptive behavior. So we have an individual who is demonstrating disruptive behavior. We've chosen to represent this in terms of intervals, right? So we're going to measure an interval of time, and if the subject demonstrates disruptive behavior during that time, then we check it as saying, yes, disruptive behavior happened here. On the graph, we're expressing that as a percentage, right? So of the intervals that we lay out, what percentage of them was their disruptive behavior? And our independent variable here is the level of attention paid to that individual. So under high attention conditions, when we're paying attention to this person a lot, we see a very low amount, in fact, no disruptive behavior. But under the low attention condition, we see a return to a higher percentage of disruptive behavior. And then when we go back to high attention, it returns to this low level. When we go back to low, it comes back up here, and so on, right? So we're able to manipulate that independent variable, the level of attention that is paid, and demonstrate a change in the target behavior and replicate it. So that's the idea. That's basically what we're trying to do here. Okay, that's it for this one. I'll see you next time.